This conference will now be recorded.
So, we had a fairly packed agenda for the ODSA track at the Global Summit. And then after we made the agenda, I had a couple of requests for speaking slots. So what I'm trying to do is I'm trying to move one of these panels to Wednesday afternoon and make room for about a session with lightning talks. Um, so so the idea is that right now I've had Acronix, Lattice, NXP, and I think potentially IRE maybe express interest in lightning talks.
What is lightning?
Lightning is just a fancy name for saying you got 5 minutes.
Oh, that's what you mean by lightning. I thought that was the name of a interface or product.
No.
There was a light peak, but yeah.
Just a 5-minute talk. So my thinking is that, we make a session with 4 or 5 companies. I'm not sure if IRE is in or not, but I know Lattice, NXP, and Acronix are express interest, and if there's anybody else. So the main reason I'm bringing it up is if anybody else wants to take a 5-minute slot to express your love and affection for the ODSA, that would be great.
Hey, Bobby, if I could, make a comment or two,
Sure.
if you mind, and you can sort of tell me what I ought to do procedurally and whether or not this is the right forum.
Four.
So let me kind of just make a couple of quick points. As you're well aware, Bobby, Netronome has had some organizational churn over the past couple of months. Meanwhile, as I think you also appreciate, key architect Gavin Stark has been working away in the background, and I think there's a pretty good view of what an open SmartNIC architecture ought to look like in terms of how that could be dissected. Obviously, like everything else, there's a million different options for skinning the cat, as it were. But essentially, what we'd like to do, or particularly Gavin, what I'd like to do is basically propose, this decomposition of a SmartNIC, and specifically with a view to building the elements that would make such a SmartNIC. So in other words, moving from, if you will, a sort of theoretical discussion to, an implementation plan that would define some of the constituent pieces, and obviously following the the work of using the appropriate interconnects in terms of performance, yada yada yada, to actually do this. There's been some discussion with Aaron and some of his team, some initial discussion. The net result of which is to basically put I guess the other aspect of the project is that it would be open, of course. So what we'd like to do, Gavin particularly would like to do, is to choose the appropriate forum to explain the architecture and the work that has been done to date, and to enlist the appropriate people to actually help contribute towards a product as opposed to an academic paper or theoretical POC. So would this be the right forum, to give Gavin a bit of a platform to review the idea and critique the idea, or would it be the POC working group?
So probably either one. Either one will work. So give me some time and I'll get back to you offline.
Okay, that's fine. That's fine.
So I think this either the Friday form or the POC form both will work in my mind. Maybe you start with the POC form and work our way up to the Friday form.
Right. Okay, that's fine. That's fine.
Fair, and so let me just track that.
And the reason why I mention it is because it might actually be a useful thing to, I don't know, announce that as an open project at the summit.
Yeah, so we can. I think we're certainly open to that. Let's see where we get in the next 4 weeks.
Okay. Well, I think yeah, that's fine. That's fine. And I was thinking more specifically. Let's see where we get in the next week in terms of buy-in.
Sure. Week is even better. These things generally seem to take a couple of weeks to roll out, but to evolve. But that's fine too. A week is even better.
Okay. Great.
Okay. Anybody else with any opens?
I was just curious. This NIC interface, is that like a multi-device, multi-chip type of NIC? Is that?
So the assumption is that there are a number of blocks or islands or whatever term you want to use to describe the constituent pieces. The constituent pieces can obviously be broken down into Macs at a variety of obviously different speeds and interfaces. Then the essential ingredient is much like the distributed switch fabric that is a core to Netronom's NIC to date. There has to be a means of moving the traffic based on some sort of decision. So essentially, the concept is to put in place a performant NIC embedded in the performance switch rather embedded in the NIC, and that could be another component. Basically, something fairly straightforward, some sort of match action type, programmable match action type switch, such that you have the data coming in, and then you basically distribute the data to, for example, an outward path, or to some sort of processing element to do some other work, whether that work is TCP termination or whatever it might be.
Thank you.
Okay.
So coming back to this lightning session, anybody else interested? Tawfiq? Any chance you guys are interested, or Jim?
Do we have to speak as quickly as you do, Babi?
Something along those lines.
So what I would suggest is, assuming that there is some interest in this idea, as I say, in a conversation with some of the folks from Facebook, if this proceeds, and if there is it is proceeding in any case, but it might be, as I say, the appropriate time to basically announce this open project and explain what it is in 5 minutes.
Yeah. Sounds good. And okay, so if anyone's interested, let me see. Is JP here? Hey, Jawad, and okay, then you're the last person I wanted to. Are you guys interested in any of this lightning slot?
I'm interested to see whether we can do a 5 minutes, 3 minutes, whatever time.
Yeah. Okay. Bill from the HFR. Okay.
Yep.
So I'm just gathering expressions of interest. I'm going to see how much I can fit together. So don't take this as it's a happening thing, but I'm going to see if I can work the schedule.
Hey, Bapi, Manish here. I was on Blue Jeans conference page, so I just joined. What is this about?
I'll sync you up offline, Manish. It's basically because of this is a follow up to the conversation you, Manoj, and I had about a speaking slot. So I'm trying to move things around and make uh,
Okay.
quick 5-minute speaking slots for different companies inside the agenda. So we're going to move one of the two panels to a different date and try to make a 5-minute speaking slot.
Sure, thanks.
Sure, Bobby, quick question. This is only for companies to talk about their efforts on ODSA.
Yes, 4 efforts on ODSA.
Yeah, so it's primarily companies which are involved and they want to do a little bit of, evangelization on what they are working on.
Exactly.
Right?
Exactly.
Okay.
The idea is that there's a whole bunch of companies who've been very active and I appreciate that in the ODSA, and not everybody has had has a speaking slot or a participation slot, and that we want to give companies an option to present if they're interested.
Got it. Okay. Thanks, Bobby.
And I'm thinking of you, Jawad.
So, Bobby, we from CDX Group, we may have made some progress on the power description format for chiplets.
Okay.
So we may be able to bring in SI2 to give a 5-minute presentation.
Okay, that's good. Now I've got enough to sort of see what a session will look like. Thanks. Okay, Vijay is here. JP will join us quick. Okay, so even if you have opens, hold it. We got to move to topic 2, unless it's somebody has a really pressing open. Okay, no pressing. Okay, so the second thing we want to talk about, and it's more like a discussion item, is that. Sorry. Oh, it's an echo. We are looking at the POC, and right now, as some of you may or may not be aware, just to give you a quick refresh, the POC is a baseboard. Oh, good, JP, it's perfect timing. Is a baseboard with 3 daughter cards, and the baseboard is a project called Mara, thanks to a nice some naming convention from Kevin. And the 3 daughter cards are for components that will be used in the POC. So our original plan was to have, and the daughter cards are called pitchlets or PCB chiplets. And our original plan was to have 3 pitchlets, one from Netronome, one from Acronix, and one from NXP. And for various reasons, 2 of the pitchlets are not happening right now, the Netronome pitchlet and the Acronix pitchlet. And the NXP pitchlet is well on its way to being designed. So the proposal that we're investigating, the idea that we're investigating, is that originally that POC card was supposed to be used inside a chassis. So the idea we want to investigate is pull the POC card out of the chassis, put it, use it outside the chassis, then build adapters for OCP NIC 3.0 and PCI Express cards so that we can use existing cards as is for the POC. That's the basic idea we want to discuss. So these existing cards would slot in perpendicular to the baseboard. So the adapter would lie on top of the baseboard, and these existing cards would slot in perpendicular to the baseboard like in a PC. And the cost of this is that the POC would move outside a chassis and would be in its own standalone box. The advantage of this is that we would use off-the-shelf cards. Somebody wouldn't have to design new cards specifically for the POC. That's the thinking. Vijay, whose team is designing the baseboard, and JP, who's leading the POC hardware effort, are online. And then we wanted to have an open discussion on what you all thought of this idea. So JP, do you have anything? Please add something.
Sure, Bobby. So I'll share my screen and present my thoughts, like what are the architectures are feasible and what can be done with off-the-shelf cards.
Oh, perfect. Let me make you the presenter. Give me 1 second.
Okay, great.
Wait. There you go.
Yeah, thank you. So, so do you see my screen?
Yep.
Okay, let me go to the presentation mode. Okay, good morning, everyone. So thank you, Bobby, for setting the stage with what we want to discuss with the off-the-shelf cards with the POC. So far, we have been designing POC for quite some time with the concept of baseboard and pitchlets, and which I'll explain in a minute. And so before that, let's actually take a step back and then I want to kind of trace the history where we started off. Right, am I right? So this is our original POC idea. So we want to put three chips, that NFP from Metronome, FPGA from Acronix, and NXP CPU in one package, what we call a system in a package. And this is what our ultimate goal was, goal is, right, to and make the interconnect work within that package. Right. So in order to execute this POC, we first actually the first we want to do a PCB validation. We want to validate the PCB first. The same concept, putting it in a package. We want to validate in the PCB, and then we want to do a software development vehicle with that PCB. We'll do the act as a software development vehicle. Not to prove the idea. So what we came out with, instead of designing a big board with three different components on it, it'll be a big task. We actually want to do a modular design, and each of these components, NFP, FPGA, and the NXP CPU, all will be in separate module. And this module is what you'll call as a pitchlet. Just like you have it on a chiplet on a package, this on a PCB, we call this a pitchlet. And this is the concept we came out with, modularize the design with three different modules for three different components that we want to have in the package for software development vehicle. So what we ended up having is actually a PCIe card form factor with three different pitchlets on it, and with some M.2 cards. What you see, this is our what we call as a base board, and the base board will host all these three modules that we talked about, what we call a pitchlets, onto this base board, right? So this is where we started off with, and Bobby came out with an idea. What if we use that? Actually use our existing cards instead of designing our own form factor, the pitchlet cards. So what if we use off-the-shelf cards, right? That can go on the pitchlet slots. So this would make it easier for trying out various chips instead of designing a new design onto the pitchlets. So what are these new cards? I mean, off-the-shelf cards. There are two form factors that is already available today that's extremely popular. One is the PCIe card form factor. So it's shown on the right. And the PCIe cards form factors are available for FPGA or Metronome part or any component. Most components are actually available in a PCIe card form factor. Typically, they have what they have is a by 16 PCIe link, and then they may have an QSFP or SFP Ethernet ports, right? So or it can have a standalone accelerator where they don't have any network connectivity, or it could be an ASIC or FPGA talking to a by 16 link. Right. The other form factor which is catching up is actually the OCP 3.1 NIC. And this is a very small form factor, and this also will have the same interface, a by 16 PCIe and two Ethernet ports, QSFP Ethernet ports, one or two Ethernet ports. Right. The question here is actually, instead of designing a new pitchlet cards for every chip that we want to actually use it on the POC, can we use this off-the-shelf existing PCI card or OCP NIC, right, onto the POC platform? Right, so there are two things that we need to check. One is mechanical compatibility, whether it will fit within the existing mechanical form factors that we have. And the other one is architectural compatibility. Right, so let's evaluate both the architectural compatibility as well as the mechanical compatibility and see how it can fit onto our platform. So let's start with the mechanical compatibility. The first one is actually OCP 3.1 NIC. So this as a form factor, as shown on the right, is about 3.3 by 4.5 inches. Right, and so the pitchlet what we have defined is actually 3 by 5 inches. So it can very well accommodate mechanically. It can be very well accommodated within the pitchlet. So the idea is you take the existing pitchlet card, and then you can design an interposer adapter board with the OCP NIC 3.0 connector, and the OCP NIC can slide on top of the pitchlet cards. Right, that is the idea. So so if in order to give a bit more context, so what we have is here we'll have on top of, let's say, imagine we are going to put this on pitchlet B, and pitchlet B will have an interposer card or a PCB with OCP 3.0 adapter, right? And on top of this adapter, we are going to slide this OCP 3.1 NIC onto this. Right, so since it's mechanically compatible, the size-wise it can fit into this. It can still work. So OCP 3.0 mechanically fits, and then let's look at the PCIe card form factor. So this is actually the PCIe card form factor, and so this is actually can go horizontally, so sorry, vertically. So this is what Bobby was mentioning about, that it can be plugged vertically into the platform, and that can be done by putting a PCIe edge finger on the pitchlet. So again, design an adapter board or interposer board with a pitchlet form factor. On top of that, you put a PCIe edge finger host connector. Right, so any PCIe card can be attached to it with this adapter. All right, so these two, so what essentially we can conclude is mechanically, with our existing POC platform definition, the PCIe card as well as this OCP NIC 3.0 card can fit. Right, that's the first thing we want to establish, and the next step is actually looking at the architecture, how well it fits into our architecture definition. Right, so before I go on to the architecture, are there any questions?
So JP, this is DJ. I have a quick question. Hi JP, I have a quick question. Is there any reason, so you explained very well what the motivation for the POC is, which is, you know, to have ability to quickly develop a software piece for this particular use case of NFP, FPGA, and CPU. Considering that that's a temporary use case, I mean, the end goal is the system in package. I'm curious to know what motivated you to consider trying to accommodate both of the form factors, OCP NIC 3.0 as well as a PCIe card form factor, because idea is to quickly go from POC into the next step, and I'm curious to know, could you simplify by converging on only one choice, which gives you good enough options to complete the goal of POC, whether that choice is OCP NIC 3.0 or PCIe card, which you show on the screen right now? So that's my first question, and I take a pause to hear your response.
Sure, DJ. Yeah, so DJ, that's a very valid question. Your question is, why do you have to consider two form factors that's the same functionality on the platform? correct? So the actually we don't need to consider both of them. This is actually kind of, we want to diversify. So we can zero it on one particular form factor. So I'm presenting both options. We have multiple options. Suppose some vendors only have OCP 3.0. This is something we can accommodate as well. So in the end, when for our implementation, we'll be choosing one. Which is what matters for us for functional or software development. We don't need to actually develop both of them at the same time for a particular product.
Okay,
This
so
is
that's
just
helpful. Right, that's helpful because OCP NIC 3.0 is gaining a lot of momentum. A lot of vendors already support it. Obviously, it's part of OCP, which is a good thing. So that's why I'm kind of, I'm obviously at all times leaning towards how much reuse can we do of OCP related designs wherever possible.
Right. Yeah, so just to want to add to that, DJ, that one of the advantages I see the OCP NIC 3.0, we would need, as we see in the next set of slides in the architecture, we would need by 4 bifurcation support for PCIe. The PCIe need to be bifurcated to the level of by 4 links, right? So my understanding is that the OCP 3.0 NIC with the multi-host support readily supports it. So they would support bifurcation down to by 4.
Right.
Whereas PCIe, I don't see that. It's only bifurcation down, PCIe card form factor. I think the bifurcation is down to only by 8. And not all cards have got this by 4 bifurcation capability. Right.
So,
if you
I mean, just going to say, certainly there are. There's exactly what you're looking for. Certainly in the OCP v2 form factor. I'm not sure whether it exists in the format that you're describing in v3. But I think that perhaps the bigger question is, this is good and this is interesting, and the collaborative initiative and demonstrating the use case is obviously all very good and very positive. I guess I would ask the question, how do we get to the next step? However, what aspects of the endpoint, how do we take the next step? And I think that's where we really need to figure out how we're going to actually build some chiplets, how we're going to adapt whatever interconnect and link layer is appropriate for the target design. And thus, I guess what is the roadmap beyond this initial effort? And clearly it's extremely valuable. But I think I would view it. I hope I'm not being unkind or anything like that. I think it's the first step that's plausible. And again, enlist those who care about getting to the endpoint. Well, the endpoint is obviously, the chiplet-based, fully integrated device.
So, Tim, you're on the money, but the POC is a vital part of where we're going. So, and we do need to we do need to figure out how to get a good supply of pitchlets going. Your point is well taken, and there's a lot of other activity on this. DJ, just to one point you made, this is not just a temporary thing, right? Like, fundamentally, we think before anybody makes a single package product, they're going to need a prototyping platform of some kind to see what it's going to look like, at least if you're going to use single packaging with today's parts. So, and this is one of the, in my mind, there's one of the big bonuses of what JP has done is allow people to mix and match parts. So,
right. No, I understand that. I completely understand. All I wanted to say is that I think, if there is a way to converge on one, to simplify, and especially on OCP NIC 3.0, that would be fantastic, because we can be forward looking, right? Where would the industry be 2 years down the line, not where it is today? And with that little bit of forward looking, we can quickly say, yeah, you know what, 80% of the possible solutions will be on OCP NIC 3.0 anyways. So yeah, let's just simplify, and when the time comes to expand beyond the existing POC, you will have all the flexibility on NIC 3.0. So that's how I'm thinking. I'm thinking of pure simplification, because when we provide flexibility, that always comes with some complexity.
Got it. Hey, JP, you probably should move on to the functional fit, because we're getting a lot of valuable feedback, and you.
Sure, absolutely, Bobby. Thank you. So let's
And
go
we're
to the
about 30
next.
minutes out. Yeah.
Yeah. So let's go to the next slide. This is a part actually, which is actually architectural fit, right? So what is shown here is what is the architecture we're currently implementing with, right? What is the architecture that we have to build a dedicated pitchlets? What did it look like? Right, so we have 3 slots, and what you see here is there are 4 PCIe ports in each of the slots or each of the pitchlets. There are 4 PCIe ports numbered from PCIe 1 to 4, and some of them can be root complex, some of them are endpoints. For instance, PCIe 1 and 4 are endpoints, and 2 and 3 are the root complex across all slots. It's uniform across all slots. And then we have 3 Ethernet ports. So Ethernet 1, 2, 3, right? So let's talk about the Ethernet. So Ethernet is something simpler to understand to start with. So Ethernet 1 and 2 in slot A and B are connected to external network using QSFP ports, right? And then slot 3 is actually the Ethernet 3 is for inter-pitchlet connectivity. So the Ethernet 3 will connect to slot B as well as slot C, and they all can talk Ethernet language within the pitchlets using the Ethernet 3, right? And then so in the slot A, we have the PCIe 1 connected to the host. It will be a dedicated connection to the host, server host, using a by 16 PCIe link. And 2 and 3 will connect to that slot B and C for inter-pitchlet connectivity, right? And same way you can actually say from Ethernet slot B or pitchlet B, you have a connectivity from B to C and B to A. And slot C is something special where we put some M.2 SSDs for storage acceleration use cases, 2 and 3. Right, so this is a high-level architecture. I mean, this is architecture that we are implementing on the baseboard for pitchlet connectivity. And if you have to replace that with the standard form factor cards, what would it change here? The change here is actually that we have 4 PCIe ports. If you add up all the numbers here, but it'll be about by 32 PCIe port. Functionally, what is active here is a by 32 PCIe link, right? So for instance, let's say slot A, which has a more number of PCIe ports. If you take this a by 16, PCIe 2 we define to be by 8, and PCIe 3 another by 8. If you add up, it will be a by 32 PCIe link. In a PCIe, if you take the OCP 3.0 NIC or standard PCIe card, it will be a by 16 link. So the bandwidth there itself is reduced by half, right? So other than that, it's still functional. It can be implemented. It still be functional. But instead of by 32 link, what we have defined for slot A, it will be a by 16 link, and that's something we'll have to distribute the bandwidth for all the connections using the by 16 link. That's the compromise we have to make if you have to use this off-the-shelf cards. And for Ethernet links, the Ethernet, anyway, these cards have got a dedicated QSFP or SFP links coming out, right? And they can be wired easily using the cables. And what we'll miss is actually slot 3. They only have Ethernet 2 and 3, and they don't have a slot 3. But using cables, using breakout cables and stuff, this is something we can manage. Again, there will be a small compromise in bandwidth, but the same connectivity that we are achieving here, can be implemented using the standard care of the shelf available cables. So we need to not execute this. We need both by 4 and by 8 bifurcation capability in the standard form factor cards. So let's actually go in one more step. Let's actually map this architecture into a standard form factor cards, which has got a by 16 PCI link, right? So what did it look like? I just made some changes here. The host and the slot A, the host would be by 8 instead of by 16. And then the 2 and 3 will have, instead of by 8, it will be by 4. So we're equally distributing the bandwidth using a by 16. So everything will become half. And PCIe 4 is not anyway used, right? And Ethernet connections, I'm saying it can be wired using cables, standard cables. So what essence, and if you look at the slot B, there isn't any changes here. So we have, we are using here by 8 or by here, and then this by 4. So we are using less than by 16 link in the slot B. So there's not going to be any change to the slot B. And if you look at slot C, which is actually kind of a surprise to me, that there isn't any change again. So if you look at here, we're already using by 8 here, and then by 4. So by 8. So essentially it'll be we'll have to probably lose actually one M.2 slot, but other than that, we still be able to manage slot C with the standard PCI card form factor, right? So what it means is there is no changes to slot B, and possibly we'll have to remove one of the M.2 slot. So bandwidth for the slot A reduces by half, and then we need to bifurcate the slot A PCI link to by 4 in order to make this work, or by 8. And also the PCI card standard in general, the PCI card form factor supports only root endpoint mode. We need to see if that OCP NIC 3.0 card or PCI card can support both root complex endpoint modes. This is something we'll have to verify with the target chip in mind. And we'll have to see how we can configure it, half the lanes into root complex mode and half the lanes into endpoint. So if it's an FPGA, it should be doable, but depending on that, let's say NIC chip that we are thinking about, some may support only endpoint mode, some will support have both endpoint and root complex, and this is something we'll have to see what the data sheet offers. Right, so we see the other thing we could do instead of compromising the bandwidth to by 4. The other possibility is actually make the link remove the link to slot C, right? So in that way you get a higher bandwidth between the two slots. For instance, we have a slot A could be a NIC chip, slot B could be an Ethernet card, and they have a full by 8 bandwidth, higher bandwidth available. So we can have a lot of we can manipulate in a way that what we want to validate in a POC based on a base architectural template. And these things can be accommodated by changing just the interposer cards. What bandwidth we want to configure can be done by just changing the interposer cards. Right, so any questions on the architecture? Next, I'll show about the implementations, like sample implementations with FPGA or an NXP cards. Is there any questions before I head further?
No, JP, keep going. We're 15 minutes away, so I want to leave at least 10 minutes for discussion and just get everybody's thoughts in.
Absolutely, yeah. Okay, so this is so this is actually a kind of smart NIC with FPGA NIC shared host. right? This is similar to architecture what we had a presentation from, I think, Haig, right? I forgot his name, so who presented from Technion Israel on the POs, one of the software meetings. This is
Yeah, the
similar to the
Millennium
architecture.
guy, Iran.
Sorry?
You're talking about the Technion grad student from the
Yeah,
Technion, right?
Technion
Yeah.
student. Yeah, so what it has is what we could do is actually we can design an interposer card that goes into slot A and B. And slot A, let's take slot A, will have a standard OCP NIC, 300 NIC card, 2 QSFP ports. And it'll connect to the via interposer to the host via by8 link. And then, so it could be by8 PCA Gen 4, and to maximize our bandwidth. And then the other part of the link, the by8 link, so totally out of by16, we are dividing one by8 that host to the host. The other by8 PCA link can go to the slot B, which is an FPGA PCA card. And we can just plug in any standard off-the-shelf Xilinx or any FPGA card for that matter in that slot. And this will actually connect to the network. This FPGA card can connect to the network to implement what is called the bump in the wire architecture. So it'll have Ethernet. The Ethernet link, USFP links can be wired using the cables. And in addition to the Ethernet link, we also will have an by8 PCA link, right? And so I think this is what the Technion student was implementing that in the SmartNIC implementation. And on top of that, in what we can also do is, since we have a by8 link connectivity between the pitchlet B and C, we could also connect to an accelerator, or it can be connected to an M.2 card on the platform, M.2 SSDs on the platform. Right. So what in order to make this happen in this existing platform, what we need is in the design is an interposer card with either a NIC 3.0 adapter or with PCIe standard PCIe card adapter, where we can plug the off-the-shelf cards onto the platform, which ensures all the PCIe connectivity between the slots. Okay, so next, actually, this is actually what NXP team was actually proposing, what they can do with the LX2 pitchlet they're designing. So here, what we have is, on the slot A, we have a standard FPGA card, standard PCIe FPGA card plugged onto the slot A interposer. And then again, we'll have a by8 home link to the host. And then another by8 is connected to the NXP pitchlet. NXP is designing a pitchlet. And I'm assuming we don't need an interposer directly. We'll put it on the platform. And and this will allow them, so this is what they want to implement their SmartNIC implementation, where FPGA, they'll get data from the network, will do some pre-processing, and LX2 can run some analytics on that, or further deep packet inspection on the network cards. Again, so this LX2 can also be connected for either for any storage use cases as well by connecting to M.2 or any other. For instance, M.2 can be even a OCP machine learning accelerator as well. So, so this is just a form, the placeholder. It can be an SSD or it can be any other form of accelerator that is designed for M.2 slot. Okay, so those are two represented use cases, but you can, of course, now you get an idea, you can actually create different use cases by mixing the pitchlets or standard FPGA cards with an PCIe cards or OCP cards with the interposer, and you'll be able to flexibly come out with different architectures for software development. Right, so that actually brings me to the conclusion or summary. So yes, the question that Bobby raised was, can we use really a standard PCIe card or OCP NIC card that is available off the shelf and use it in the platform? The answer is yes. So there's a small compromise you have to do in the bandwidth, but I think it's still worth it because it's something will get us going quicker. And so there's one more thing that is actually, if you go with this path, what we'll miss is really the management interfaces. So right now we're planning a lot of management interfaces that would require a dedicated pitchlet. Management interfaces being from the lattice pitchlet that will control this, that will implement the security features, and that won't be available in PCIe card form factors. And for the, if you have to have those features available, one needs to design a dedicated pitchlets. But other than that, it looks to be a very good idea that will get us going with the existing cards and allows us to flexibly compose architectures on the fly for software development. Yeah, back to you, Bobby. Any questions?
No, hey, so for everybody else on the call, JP turned this around in 48 hours. I think we had this discussion on Wednesday evening. So a huge thank you for giving it this much thought and coming back to us as a group. Thank you.
Sure, yeah. Sure, Bobby.
So I guess you know, if you don't mind, Bobby, I would pose the the next and obvious question is the scope and benefit have been very well articulated. Is there anyone signed up to develop any software? And I guess the real hard question is, this is very good, very interesting, but obviously it's never going to ship in production, of course, for the reasons which don't need to be stated. So what is the intention that this try to be a vehicle for software development? Who's developing that software? What timeline? What sort of milestones along the way? And then I guess the question is, and then what? What's the next step?
Right. So yes, we are beginning to get sight of software resources. And the idea is that the three pitchlets which form the two or three pitchlets which we get into the POC will be available as bare die, and we make a package part from them. And the software that is tested and developed on this POC board will migrate to the package part as is. And the thinking is for generation one, there's going to be interest in taking existing parts and packaging them together. And this board is a clean development vehicle to combine arbitrary parts, see how they play together, and develop a software infrastructure for that, and generate a package part. And that generation two of chiplets will actually have dedicated dedicated interfaces. And one of the options on chiplets is to actually use PCIe over a die-to-die interface. We've made tremendous progress. So you could take the package part that you made from this POC, replace the PCIe file layer with a die-to-die file layer, and the whole thing should still work. So that's a sequence of action. So that we were beginning to gain sight of software resources. You develop software, you make a first generation package part with existing die, with existing die, and second generation you replace the PCI PHY with the die-to-die PHY, and you should still be able to inherit the software infrastructure as is. And as a group, we're developing there's two open PHYs in flight. There's the bunch of wires PHY, and there's a Open HBI and Intel's AIB. And then on top of that, we made tremendous progress in defining a pipe adapter so that you can carry PCIe traffic transactions on a die-to-die PHY. So there's a very clear path from here to a chiplet library.
I think that there's a certain, what shall I say, a certain wishfulness in that line of sight. I mean, again, I think as we all appreciate, the key and critical things are in any ultimate solution. The data flow analysis and the performance are key and critical aspects. And okay, fair enough. Perhaps I'll hold my tongue at that point.
All right, sounds good, Jim. Anybody else? DJ, Kevin, Jawad, Rita?
Okay.
Yeah, I think Bapi, this is an excellent idea, and eventually we can even think of pushing it further by looking into redesigning the baseboard itself, perhaps, which can directly accommodate OCP NIC 3.0. In fact, I'm kicking myself as JP was describing that we, for some reason could have intercepted this thought so much earlier, because OCP NIC 3.0 is such a prominent project within OCP, and it's only gaining steam. And partly it's because modularization has become a very core focus in the incubation committee, which we meet every 6 weeks, and we might be taking OCP NIC 3.0 into even a bigger project, driving all modularization. So I think this is an excellent effort towards that direction.
Great. I think it was originally triggered by either Kevin or JP. Somebody had this idea of let's move the card out of the chassis, and then that sort of freed us up a bit.
Right. And yeah, I mean, bringing in existing form factors to reuse, I think that's exactly the way we should think at all times, especially OCP driven form factors.
I'm with you, man. No PCI. Okay. Jawad?
So I think this is a pretty good idea to expand the library size for P chiplets by creating adapter boards. So I like it.
Anyone else with any thoughts, concerns? I mean, there's a ready-made library of 3.0 NICs that I think we can sort of, there's a couple of 100 2 by 100 gig NICs that I have my eye on. So.
Mm-hmm.
So I have one quick question for JP. JP,
Yeah.
beyond what you summarize in terms of bandwidth being reduced half, which is more an architectural performance impact, I'm just curious to hear your thoughts. Having an adapter card, does it in any way adversely affect performance, in your opinion?
No, other than the bandwidth, it should not affect the performance. Whatever bandwidth we can pass through, that's the one we should. That's the impact in terms of performance. Other than that, it'll bring the native performance, except for the bandwidth.
Okay.
My understanding is that we are not really concerned about this, really validating the performance in this architecture. We're just validating the concept software behind that. And if you architect the software such that it can scale the performance as we increase the bandwidth, we go to package form factor. And that would be the way to go. And this is the vehicle for us to validate without putting ourselves constrained by performance.
Right. Okay. Understood. So looks like, when the OCP subgroup starts thinking of 4.0, we should influence their thought process by requesting some additional PCI lanes, which could help, So that's another thread we should keep in mind, is to go back and tell OCP NIC 3.0 group that, hey, this is our wish list.
Absolutely. Absolutely. Do you know the OCP 4.0 efforts are kickstarted?
Yeah, I will get back to you with that data. I think it's very easy for us to quickly find that. So let me take that as an action item, and JP, I'll close with you.
Sure, absolutely. Thank you, DJ.
Anybody else with some thoughts? Kevin had some a sideband thought that companies who participate with this have to be prepared to hand over bare die for package parts. So I've marked that in the notes as well.
Mm-hmm.
Okay, someone else say thank you to JP, not just me. He really turned this on in 48 hours. So yeah, we really owe him a big thank you, guys. So
Yeah, sure, Gopi.
Thank you.
Ashish, thank you. Yeah.
Rita, anything else?
The panel finalized all the panelists. I'm going to send the final as of last night. So I'm going to send the final email, meaning finalizing and shaking hands and coordinating for the slides and all that. One question I had is about the registration. I still have not heard back from the organizers. Should I give them a call or do you have an update?
Don't blame them. It's me. I have to fix it. It's you.
Okay, so I need a code for these guys, and if the people who have signed up, how do they get refunded, things like that. That'd be great.
Yeah.
So I'll send you the email with the list.
Sounds good.
And you were talking about, sure, and you were talking about switching. The problem is some of these guys are traveling for that panel and already coming for the 5th.
Yeah, it's most likely going to be the 5 panel. Don't worry about it. I'm likely leaning towards moving the 5 panel.
I appreciate it. Thank you. That's all I have. Thank you.
Okay. Okay. So these are my notes. Hopefully you can see them. And if anybody has any corrections, any corrections, let me know. Other than that, this is great. It's been a great meeting. Thank you all. Enjoy the rest of your weekend, and see you next Friday.
Thank you for your time. Bye-bye.
Thank you.
Thank you.
Thanks, everyone.
Thank you.